Okay, so this is where we left off the other day. We were graphing inverses. So we were looking at these two functions, and first we decided we were trying to figure out if they were inverses or not. And so we did the composites, and we found that they both equaled x. So what I want to show you guys today is how to graph both of these functions, and then there's some things we can look at with graphing to show that they are inverses of each other. So first what I'm going to do is I'm going to take f of x here in green. I'm going to go ahead and graph it. I'm going to do an xy chart. Now, I know this is just x to the third shifted up 1, but what I'm going to do is go ahead and do my xy chart. So when I plug in 0, I get 1. 1 is 2. 2 is 9. Negative 1 would be 0, and negative 2 would be negative 8 plus 1, so negative 7. I'm going to go ahead and graph those points. Okay, so we can see f of x here in green. All right, now to graph the inverse, I can do another xy table for g of x. So it's the cube root of x minus 1. So for example, when x is 1, I get 0. When x is 0, I get the cube root of negative 1. When x is, let's see, negative 7, I'll get the cube root of negative 8. And what you're starting to see is that these points are just reverse of each other. So if I put in a 2, I should get the cube root of 1. When I put in 9, I'll get the cube root of 8. So if these are inverses, you'll see that the ordered pairs are flipped from each other. I can graph them here as well. So 9, 2, 2, 1, 1, 0, 0, negative 1, negative 7, negative 2, and I get this right here. Now, something special about inverses, if you take your ruler and you graph the line y equals x, so that's a line that cuts through 0, 0 with a slope of 1. Make it a dashed line. Mine doesn't look very dashed here. But you can see that that's going to be a line of symmetry. So y equals x is a line of symmetry for inverse functions. All right, let's move on to the next example. Okay, remember we talked about one-to-one. For a function to be one-to-one, it has to be a function first, which means it has to pass the vertical line test. And to be one-to-one, it also has to pass the horizontal line test. So in other words, we have no x's repeating for being a function. Oops, let's see here. I picked this pin, I think. And for one-to-one, that means no y's repeat either. All right. So what we're going to do is we're going to look at each set here. I know it's a function, it says so. I'm looking for repeating y's, and I don't see any repeating y's. So this one has an inverse, so it's 1-to-1. So we're going to say f inverse is the set of ordered pairs, and I'm just going to flip them around. And we just saw that with our last graphing problem. All right, so there's our inverse function. Now when I look at g, I can see on g that I have some 5's that are repeating, and I also see that I have some 2's here that are repeating. So I have some repeating y's. So even though it is a function, this function is not one-to-one. And if it's not one-to-one, we say that f inverse does not exist. Okay, moving on from here. All right, with these problems, we're going to see if it's one-to-one. If it is, we're going to find the equation, and then we're going to graph them both on the same coordinate plane. For some of these, it's going to be easiest if you look at a graph first. I know if I graph the absolute value of x, I'm going to have this V shape. It's kind of centered here at 0, 0. And I can see right away that this does not pass the horizontal line test. So it's not one-to-one. F inverse of x, let me back that up a little bit. F inverse is all you have to say, does not exist. All right. B, 4x minus 7, y equals 4x minus 7. That's going to be a line. Y-intercept is negative 7. 1, 2, 3, 4, 5, 6, 7. Slope is 4. 1, 2, 3, 4. 1, 2, 3, 4. And so it's this line right here. Now you guys can see that it does pass the horizontal line test. And so what we're going to do here is we're going to do two things. We're going to now, it says, let's see, find the equation and then graph them on the same plane. Okay, so we need to walk through how to find the equation of the inverse. So there's some steps you have to follow. And the first step is going to be to take f of x out and call it y. The second step is going to be to take your x and your y and swap them around. Let's do that in blue. Okay. So x and y trade places. The third step is to solve the equation for y. Okay. The fourth step is to call y f inverse. And so when I grade these, I do look at, did you call it f inverse? This is going to be super important. You have to give it a new name, and you guys will get points taken off if you don't. So make sure you do call it f inverse. Now we're going to go ahead and graph that. I'm just going to go back and write it in slope-intercept form. So that tells me I have a y-intercept of 1 3/4. Let's see, I'll graph it in pink. So 1 3/4, and then I'm going to rise 1 and run 4. 2, 3, 4. Fall 1, 1, 2, 3, 4. And there's our new line. So there's f inverse. Now remember the trick I showed you with graphing. If you graph y equals x, you should see that line of symmetry coming right through there. Okay. There's the equation of your inverse, and moving on. All right, C. This is x to the third plus 5, so I know it's x to the third, 1, 2, 3, moved up 5. So it's this guy right here. Now, if you need to, you can go ahead and do an xy table for f of x. I didn't need one because I know x to the third does that, and it's up 5. But if you struggled there, 0, 5, 1, 6, negative 1, 4. Those are the points I used. It is going to pass the horizontal line test. It is 1-to-1. So what we're going to do here is we're going to find the equation of our inverse. So step 1, set it equal to y. Step 2, swap x and y. Step 3, solve for y. Let's see here, that'd be x minus 5. And that's the cube root then of x minus 5. And step 4, f inverse of x is the cube root of x minus 5. Now, I don't have to make a new xy table here. All I need to do is graph these points, but flip them around. So if I'm graphing the inverse, all I need to do is flip my points around. So 6, 1, 1, 2, 3, 4, 5, 6, 5, 0, 4, negative 1. And again, y equals x should be that line of symmetry, cutting your graph in half. Okay, part D. So this says I have a parabola. It is shifted at 4, but this means I only want to graph the right side because x is greater than or equal to 0. So 1, 2, 3, 4, 1, 5, etc. So you guys can see that I do have a one-to-one function here. Let's go ahead and find our inverse. So step 1, step 2, step 3, solve it for y. Let's see, y squared equals x minus 4. Y is the square root of x minus 4. Okay. Let's see here. 0, 4 was an ordered pair, so 4, 0. 1, 5 got me here, so 5, 1 would get me there. And there's my inverse. Okay, let's go back here. This is going to be f inverse. This is f. And I do need to finish out down here with step 4. And we've got it done. All right. This is number 47. It's asking you if these two are inverses of each other. Now this goes back to the definition of inverses, which means you have to show composites. So we want to show both of these two things. So let's start by taking g of x and plugging it in for f of x. First, I'm going to rewrite them. All right. So I'm going to plug g of x in for x right here. So this is going to go in right there. And what I'm trying to do is manipulate this to where I get x back for an answer. Okay, common denominator there on the bottom. So I've multiplied here by x over x. All right, well, I have 12x plus 6 over x. I don't know about you guys, but that's not looking anything like x. So what I can do is I can kind of keep on going to show you that it's just not going to work out for us. I'm going to multiply by the reciprocal because that's how you divide fractions. You multiply by the reciprocal. And I get 2x over 12x plus 6. Now I don't need to go any further. That is not x. So I can just say that f and g are not inverses of each other. And that takes care of that problem. All right, as you can see, that's the end of our 4-1 notes. Let me know if you guys have any questions.